Okay, hi. So welcome to the June 2015 paper for chemistry. This is C1, so Unit 1 in chemistry, and it is obviously for AQA. If you're taking the foundation paper, then there are going to be some questions in here which won't apply to you. But as usual, let's start with question 1. Alright, so question 1 says this question is about atomic structure and elements. Complete the following sentences. The atomic number of an atom is the number of, you should know that that is the number of protons. Alright, so that's easy, 1 mark. Part 2 says the mass number of an atom is the number of, okay, and the mass number of an atom includes the number of protons, but it's not only the number of protons, it's also the number of neutrons, because the nucleus contains protons and neutrons. So I'm going to say protons again and neutrons. Okay, alright, so easy so far. Now question 1b says explain why an atom has no overall charge and use relative electrical charges of the subatomic particles in your explanation. Okay, so that's the thing I'm going to say first. I'm going to say that protons have a +1 charge and electrons have a -1 charge. Alright, those are relative charges, obviously not real charges measured in coulombs. Okay, and then why does an atom, okay, that's the important part, an atom have no overall charge? Because in an atom, the number of protons and electrons are equal. Alright, and that obviously means that the charges of +1 and -1 cancel each other out. Alright, so next question. It says, explain why fluorine and chlorine are in the same group of the periodic table, giving the electronic structures of both in your explanation. Okay, so first of all, I'm going to say that fluorine has electronic structure. Now, you get a periodic table in the exam, so you could just check this, but it has the electronic structure. And that is 2, 7, right? So fluorine is in group 7 and it is the first element in group 7, and so that is the structure. Okay, chlorine is also in group 7. So chlorine has the electronic structure. 2, 8 because the next shell is also full, and then 7 because it's also in group 7. So when it says why are they in the same group of the periodic table, they are in the same group because they both have the same number of electrons in the outer shell. So as both have same number of electrons in the outer shell. Alright, outer shell or outer energy level. Alright, and that's more than enough for 2 marks. So 1D. Figure 1 shows the electronic structure of an atom of a non-metal, and we're asked to tick which one that non-metal is. So what we would do is we'd look at the electronic structure of this element. Now obviously your inner 2 shells, so this one here and then this one here, they are both full. So you've got the electronic structure 2, 8, and then what is in the outer shell? Well, we have 1, 2, 3, 4, 5, 6. So it is 2, 8, 6. And so we are looking in the periodic table for something in the third period, so the third row, which is in group 6, and that is sulfur. Okay, so we're going to tick sulfur, and that is our answer. 1E, it says when elements react, their atoms join with other atoms to form compounds. Complete the following sentences. Compounds formed when non-metals react with metals consist of particles called, we should know that metal plus non-metal gives you ionic bonding, and that is a result of particles called ions. Okay, compounds formed from only non-metals consist of particles called, well, this is when you have covalent bonding, and covalent bonding in general will form molecules. Okay, there are a few exceptions like silicon dioxide and diamond where you form giant covalent structures, but in general, non-metals will form molecules. All right, and that brings us to the end of question 1. Question 2 says limestone is used to make many different materials. That's true. Heating limestone produces calcium oxide and carbon dioxide. Complete the following sentences. The main compound in limestone is calcium, or you should just know that that is calcium carbonate. All right, calcium carbonate. Part 2. The reaction to produce calcium oxide from limestone is a thermal, and that is thermal decomposition, right? Because you break down one substance into more than one substance. So it's decomposed using heat is thermal decomposition. Next, calcium hydroxide is produced when calcium oxide reacts with, well, hydroxide. The hydro there gives you a clue, and it is reacting with water, right? Hydroxides aren't always formed by reacting with water, but that is one way that they're formed. Calcium hydroxide is used to neutralize acids because it is what's the opposite of an acid? Is an alkali, right? You could have said base, but because it says an there, okay, that tells you that it's going to start with a vowel, so it's an alkali, and that's true. Calcium hydroxide dissolves, so it is an alkali. All right, so moving on. We've got 2b. Cement is made from limestone and clay. Concrete is made by mixing cement with water, sand, and aggregate. A group of students did an investigation on the amount of aggregate needed to make the strongest concrete beam. The students used the following method. Use the same mass of cement and the same mass of sand, but change the mass of aggregate to make 7 different concrete mixtures. Use the different concrete mixtures to make beams of the same size and add weights as shown until the concrete beam will break. All right, and then we have plotted results on this graph here. Okay, so let's move on and have a look at the questions. B part 1 says one of the points is anomalous. Complete the graph in figure 3 by drawing 2 straight lines of best fit. All right, and these are going to be not totally straight because I'm not using a ruler. But if we have a look, 2 lines of best fit, well, I mean, one's easy to see, it's here. Okay, a straight line would go straight through those points. The other one is obviously going up. But the straight line, I would say that this point, and this point are all lying on a straight line. This one looks like it might be off. Okay, so if I draw a straight line, let's get rid of those rings. If I draw a straight line, that's my line of best fits, right? If I had a ruler, it'd look better. And you can see that this one doesn't fit the trend. And so I would say that that one is an anomalous result. So those 2 lines, there we go, those 2 lines are your lines of best fit. All right, now in B part 2, it says describe one way the students can improve the method so that their results are more accurate for each graph point. Okay, now importantly here, it's not asking us to take new measurements at different masses because it says so that the results are more accurate for each graph point. So the graph points we've already got. So what we're going to be doing here is we're going to be doing repeats. So we're going to say we can repeat the experiment for each mass of aggregate. All right, that's 1 mark. And then how would that make the results more accurate? Well, we'd take an average. Okay, so we would average, so there we go, average the results. Okay, and when I say average, what I'm really talking about is the mean. Okay, so take an average of the results, and that is worth 2 marks because taking the average is 1, and you've taken the average after repeating the experiment. B part 3, what force is needed to break a concrete beam containing no aggregate? Show you're working on the graph. All right, so no aggregate, we're going to have to extend this line of best fit, right? So you would do this with a ruler, but I'm going to extend and say about maybe there, okay? All right, and so from my graph, if I look carefully, that's 1 square above 40, all right, and each square is worth how many? Oh, sorry, each square is worth 2, so that would give me a result of 42, okay? Let's just bring that back, like so, there we go, because each square is worth 2. So that would have given me a result of 42, and that would be my answer on the next page. Okay, force would be 42. and they've given the units, so I don't need to write the units in. Importantly there, you could not score full marks if you did not use a line of best fit. They would have given you 1 mark for taking a guess, but as long as the guess was around the correct value. Alright, so B part 4, it says one of the students concluded that the force needed to break a concrete beam increases as the mass of aggregate increases. The student's conclusion is not completely correct. Use values from the graph to explain why. Alright, so let's have a look at the graph again. Obviously the reason we've got 2 lines of best fit is because this statement is not true the whole way. If it was true the whole way, we'd just have 1 line best fit which kept going up and up and up and up and up. But we don't, it goes down after this point here. So what I'm going to say is that from 100 to 400 grams, the statement is true. Okay, so from 100 grams to 400 grams of aggregate, the statement is true. Okay, that shouldn't have been a capital there. Now, however, after 400 grams, the force required decreases. Alright? And what I would also do is I would use figures. So I would say force at 100 grams is equal to, I'd have a look at the graph and say, well, the force at 100 grams is 60, 62, 64, about 65, right? 65 newtons equals 65 newtons. Okay? At 400 grams, so this is going to show it's increased, well, that force is equal to, here we go, 150 newtons, so it's clearly gone up. 150 newtons. Okay, then I'll say, however, and let's have a look at one, let's say 700 grams, we'll use that one. 700 grams, it equals 100, so it's gone down. Okay, so at 700 grams, it equals 100 newtons, and I'd say, therefore, statement is not correct after 400 grams of aggregate. Okay, and that is the end of question 2. Now moving on, question 3 says that this question is about life. That's nice, the Earth and its atmosphere. There are many theories about how life was formed on Earth. So just one reason why there are many theories. Now you could have got the marks for a couple of answers here, but the main reason is that this occurred many years ago, okay, billions of years ago, and so we weren't around to observe it. Okay, so occurred many years, I'm going to put billions in brackets here, many years ago. Alright, that's more than enough for 1 mark. If you wanted to say something different, you could say that we don't have enough evidence to prove one theory or another. Okay, that would also have got you the marks because it's completely true. Many different theories could all be true. We don't have conclusive evidence as of yet. Alright, so 3b, it says, in this question you'll be assessed on your English, okay? It says, this Earth and its atmosphere today are not likely the early Earth and its atmosphere, right? And we have this diagram. You've got the early Earth, where it's mostly covered in volcanoes, and you've got the Earth today, where it's mostly covered by oceans, okay? And that's obviously true. We're also told about the atmospheres. Most of the atmosphere was carbon dioxide and water vapor in the early Earth, whereas now most of it's nitrogen and oxygen. Alright, so it says, describe and explain how the surface of the early Earth and its atmosphere have changed to form the surface of the Earth and its atmosphere today. Alright, so what we need to describe in this question are the differences in the components of the atmosphere, so the carbon dioxide and the water vapor, and the differences in the components of the surface, which includes the solid surface, the volcanoes in the early Earth, and now the oceans, obviously, which are made of water. Okay, so the first thing is that very early on, we had algae and plants which evolved whereas they didn't exist in the really, really early Earth, okay? But once they evolved, they use carbon dioxide and produce oxygen, okay? And obviously now we have oxygen, a lot of oxygen in the air, not a lot of carbon dioxide. So I'm going to say that plants and algae evolved in the early Earth. They use CO2 for photosynthesis and release oxygen. Okay, so therefore CO2 levels go down, O2 levels go up, right? You wouldn't write it in those sort of bullet points because you're marked on your English, but this is just to get the points across. All right, what about the water? Well, as the Earth cooled, so cooling occurred. Okay, let's just put points. Cooling occurred, causing condensation of water vapor, producing liquid water, which obviously forms the oceans. All right. And why did cooling occur? Well, part of the reason why cooling occurs is because the CO2 was going down. And so as the CO2 goes down, CO2, you know, is a greenhouse gas. And so that means that the temperature of the Earth's surface would decrease. Okay. So you could write that as well. You could say that CO2 reduction reduced temperature. Okay. One thing to note is that now that you've got your oceans, or you've got your liquid water, oceans are actually a massive sink for carbon dioxide. They will dissolve carbon dioxide, and so increasing the amount of water further decreases the amount of CO2. So the oceans dissolve CO2, which leads to CO2 levels going down further. All right, now, what else happened? Well, Earth cooling. I'm just wary that my handwriting has been shocking so far, so I'll try and improve that. So the Earth cooling caused volcanoes to form crust. So the molten magma, as it cools, actually forms crust, which is obviously the land, leading to continents being formed. Alright, now you wouldn't need this many points in the real exam. This is just to show you how many points you really could get. For the exam, you need 2 or more, okay? You need at least 2 or more explained in detail, right? So if you just said that cooling led to oceans, okay, that's not enough because you haven't said that cooling actually leads to the condensation of the water vapor, producing liquid water, which obviously forms the oceans, right? So you need to go into detail for the points, and you need at least 2 of them to get the full marks on this question, okay? We've made 5 points in this question, and so obviously that is more than enough. You would only need to pick 2 or 3 of them and go into detail. Okay, so moving on. We have question 4. We're told that this question is about metals, and figure 4 shows the metals used to make pylons and the wires of overhead cables. And the wires, you can see, are aluminium, and the pylons are made of steel. Right, so 4A says that an ore contains a metal compound. Metal is extracted from its ore in 3 stages as shown in figure 5. It says explain why stage 2 needs to be done. Well, from figure 5 we see that stage 1 you mine the ore itself, so you need to get the ore. In stage 2 you separate, right? So you separate, what you're separating really is a metal or a metal compound from the rock. And in stage 3 you extract the metal and have the pure metal. Alright, and so what we need to do in stage 2 is we are separating Impurities. So impurities present in the ore need to be removed. And bear in mind that an ore is a rock containing those metal compounds, and so the rocks must also be removed. Okay, moving on. We've got 4b, and it says that cast iron from a blast furnace contains 96% iron and 4% carbon. Cast iron is not suitable for the manufacture of pylons, and give one reason why. Now, cast iron itself, because of what it's made up of, is not the strongest metal. And the main thing, though, is that it's brittle, right? Cast iron, without refining it, can be cracked if it's hit or struck with a large amount of force. So, the main reason is because it is brittle. Alright, it's brittle, and that's obviously not what you want for a pylon, which needs to withstand a lot of weight and a lot of force. Okay? Alright. 4b part 2, it says that most cast iron is converted into steel, as shown in figure 6. Describe how cast iron is converted into steel using figure 6 to help the answer. Alright, so if you have a look, you start with cast iron here and you end with steel down here. And what is actually happening in the furnace, oxygen is going through and you are forming waste gases in the end. And if you think about what cast iron is, it's 4% carbon. Right, that 4% carbon needs to be reduced, and so we need to get rid of some of it. That's the oxygen's job. So oxygen, okay, oxygen will react, okay, will react with the carbon in cast iron, reducing the amount of carbon. Okay, so you reduce the amount of carbon. This waste gas that's given off is of course going to be carbon plus oxygen makes CO2. Alright, so you could put that in there as well. That reacts to form carbon dioxide, and carbon dioxide is released. Alright, but that's more than enough for the marks on that part of the question. So 4c, it says aluminium and copper are good conductors of electricity. State one property that makes aluminium more suitable than copper for overhead cables. Now you learn that one of the main properties of aluminium is the fact that it has a very low density in comparison to its strength. Alright, and copper certainly doesn't. Copper is fairly heavy. So aluminium has a low density, right? Because for overhead cables you don't want it to be really heavy, and a dense material will make something heavy. 4c part 2, how can you tell that copper is a transition metal and aluminium is not a transition metal from the position on the periodic table? Okay, so quite simple. Copper is in the middle block. If you look on a periodic table, copper has the symbol Cu, and so it's in the middle block, and I'm going to put in brackets there, the transition block. Okay. Aluminium is in group, there we go, group 3 of the table, and so is not a transition metal. Alright, so finally part 3, we're told copper can be extracted from solutions of copper salts, okay, by adding iron. Explain why. Now you should know that copper is a very unreactive metal, and the way that we can get rid of an unreactive metal from a salt is by displacement with a more reactive metal. Okay, so iron is more reactive than copper. and so will displace copper from its salts. Okay, so displacement reaction occurs, copper is displaced from its salts. And that's the end of question 4. So question 5. It says that crude oil is a fossil fuel, and describe how crude oil is separated into fractions. Alright, and so you should know that this is via fractional distillation. So I'm going to say that crude oil is separated by fractional distillation. Alright, so now we need to actually describe that process. So the crude oil is heated to a vapor. There we go. And then passed into the column. Okay, so the column is hot or hotter at the bottom, and cooler at the top. Okay, so I'll put in brackets here that they're passed into the column at the bottom, right, not at the top. Okay, so hotter at the bottom, cooler at the top. And what happens then? When a fraction reaches, let's rewrite that, reaches a temperature, a temp below its boiling point, it condenses to a liquid, and is collected. Okay, that's more than enough for 4 marks. Alright, so let's move on. It says that fuel oil is one of the fractions from crude oil. Power stations burn fuel oil to generate electricity, and the waste gases from the combustion of fuel oil contain carbon dioxide, water vapor, sulfur dioxide, and oxides of nitrogen. The waste gases are passed through a suspension of limestone in water. Limestone is mainly calcium carbonate. Suggest how the use of a suspension of limestone decreases one of the environmental impacts that the waste gases would cause. Alright, and so there are 2 answers to this, because limestone in water, limestone will actually make an alkaline solution. Alright, and that is obviously going to counteract some of the pollutants from burning fuel oil. So let's use that one. Okay, so acid or acidic gases, such as sulfur dioxide is an acidic gas, and nitrogen oxides are also acidic gases. Right, you should know that the non-metal oxides are acidic in general, and nitrogen oxides form acid rain. Okay, so limestone suspension will give an alkaline solution which will neutralize the acidic gases. All right, so we will neutralize the acidic gases, and that will obviously stop acid rain from forming. That's more than enough for 3 marks, right? The other way you could have gone is you could have said that carbon dioxide is a greenhouse gas. All right, carbon dioxide will dissolve in a suspension of limestone, okay, and that will reduce the greenhouse effect, okay. Either of those would be fine for 3 marks, but you have to say how they cause the pollution and why the suspension of limestone would reduce that. All right, so moving on. We've got 5C. It says some fractions of crude oil contain large hydrocarbon molecules. Hydrocarbon molecules such as decane can be cracked to produce smaller, more useful molecules. You should know this. Cracking is a process you should know. So write the correct formula of the third product to complete the chemical equation. You do not need to give the name of this product. All right, and so what this is balancing. All right, you should know that cracking really produces one alkane and the rest will be alkenes. And as far as I can see, we already have an alkane, and so our answer is going to be an alkene. But it's even simpler than that. All you have to do is count the carbons and the hydrogens. So we've got 10 carbons here. Okay, so I'm going to say 10. And here we have 5 carbons, 3 carbons. So how many more to make 10? Well, 5 plus 3 is 8. 10 minus 8 is 2. So we're going to have 2 more carbons produced, all right? Now the hydrogens I'll do below. You've got 22 hydrogens on the left hand side. On the right hand side we've got 10 and we have 8. So 10 plus 8 is 18. 22 minus 18 will give you an answer of 4. So we need 4 hydrogens, right? C2H4. It says you don't need the name of the product, but you should know it's ethene. All right, moving on. Pentene is used to produce polypentene. Complete the equation and the displayed structure of polypentene. All right, and so what we need to do here is have a look at the left-hand side, and we have our monomer. We need to write that in polymer form, okay? And so I'm going to fill in. First thing is just it's a single bond between the 2 carbons, right? That's the first thing that you need to know. Everything else here is going to be the same, and here we have C3H7, which makes it pentene. Now, the bonds from the carbon extend because we can now bond those carbons with more things, right? So they extend outside the brackets like so. And because we have n lots of them on the left hand side, you put an n here on the brackets, and that is 3 marks. All right, some polymers are described as smart polymers. Suggest one property of a smart polymer that is different from that of an ordinary polymer. All right, now what smart polymers can do is that they can return to their original shape when something happens, okay? So we call that shape memory. And for 1 mark, all we need to say is that, I'll write it out fully, that smart polymers have shape memory. All right, normal polymers don't, and smart polymers do. So that is the difference. Okay, moving on. Okay, question 6. It says useful materials including foods and fuels are produced from plants. Correct. Some plants have seeds that contain vegetable oils. Give one reason why vegetable oils are important foods and fuels. All right, so important foods and fuels. The reason they're important for both is because they contain energy, right? So what I'm going to say is that veg oils contain energy, and that is enough. Next, A part 2, it says state 2 main stages to extract a sample of vegetable oil from seeds. All right, and so the first thing that you need to do to a seed is crush it, okay? So we need to crush or squash the seeds, okay? And then there are a few things that you have to do, and it's not always the same process, but what you should be doing is pressing, and by pressing we mean we're getting all the liquid out of it and not the solid, okay? So crushing is just breaking it open. Pressing, we're getting the liquid out of it, obviously, which is the oil, and then after that we are going to separate the liquids, okay? Even though it says state 2 main stages, those were 3 main stages, so we only need 2 of them, okay? So we crush the seeds, and we also press to obtain liquids. Okay, so moving on, 6b, it says, one property of a vegetable oil gives the oil an advantage over water for cooking foods, and explain how. Alright, so with oils, the reason why you can go and get some fast food, and it's not good for you because it's using fats, obviously, but the reason why you can get the food fast is because it will cook things quicker than without using the oil. The reason for that is because vegetable oil has a high boiling point, right? So over water, the vegetable oil has a higher boiling point than water, meaning higher temperatures can be used. Okay, this allows food to cook faster. Alright, and moving on, we've got 6C. It says vegetable oils and water do not mix, right? You should know that already. It says an emulsion is made by shaking a vegetable oil and water with an emulsifier, as shown in figure 7, right? So that's the emulsifier there. Underneath it says explain how the emulsifier molecules are able to produce an emulsion that is a stable mixture, containing the vegetable oil and water. Use the diagram of the emulsifier molecule to help you to answer this question. Alright, so the first thing I'm going to do is I'm going to draw a poorly drawn diagram which copies that of the emulsifier molecule. Okay, and I'm going to label the head and I'm going to label the tail. And this head is what we call hydrophilic. Okay, and the tail is what we call hydrophobic. Alright, and so in my explanation I'm going to say that emulsifiers or emulsifier molecules would be better consist of a hydrophilic head and a hydrophobic tail. Alright, so the head is attracted to the water and the tail is attracted to the oil. Now the tail, I'm going to say, the tail is buried inside oil, forming droplets, and the heads are attracted to the water. Okay, finally, why are they interspersed throughout? Because the droplets now repel each other, and so are consistent throughout the emulsion. Alright, so you need to know that the hydrophobic tails bury into the oil, and the hydrophilic heads, they like being surrounded by the water. Thus, they don't like being surrounded by each other anymore, and the droplets are going to repel each other, right? Because the heads of the emulsifiers don't want to be around each other, they want to be around water, right? So they repel each other, and so you have a consistent spread of the droplets throughout your emulsion. Okay, and that's seen in things like milk as well, right? Milk is an emulsion because you've got fats in water, and that's what milk is. Okay, and that is actually the end of the entire paper. So I hope that wasn't too fast for you, but if it was, feel free to go back and go at your own pace. Okay, but I hope you're able to follow, and I hope this video was helpful to you. If it was, please do like and subscribe because it really does help me out. But if you still have questions, feel free to post in the comment box below and I'll be sure to get back to you, or send me a direct email using the link in the description box. But at the time of making this video, we are very close to the science exams, the GCSE exams, so I'd like to wish all of you good luck with your exams as well, and I look forward to seeing you in the next video.